Hi everyone, in this video we're going to walk through some really basic examples to get us going on what logs mean and how they work. So what we're really going to be using in both of these examples is the fact that if you know that y is equal to b to the x, you also know that log base b of y is equal to x. So just because we've defined the log to be inverse of the exponential statement, if your exponential statement inputs an x and outputs a y, your log statement should input that y and output that x. So these two statements are completely interchangeable, and we're just going to practice swapping back and forth and see what that tells us about logs, see if we can start making some sense of them. First, we're going to take log statements and turn them into exponential statements. So I've given you four true statements, four true log statements. I've given you all the information, and I just want to rewrite that in exponential form so we can see what's really being said by these log functions. The first one says log base 2 of 32 is 5. If I want to rewrite that as an exponential statement, the base, the subscript on my log, is automatically the base of my exponential statement. The log is always going to equal the power that I'm supposed to use, so logs represent exponents. The 5 is the power that I would apply to my base of 2, and the number inside the log, so this is log of 32, 32 is being plugged into the log, is the thing that we get when we raise 2 to the 5th power. So we want to get to the point where it becomes really second nature for us to look at this and say, okay, this is saying what power of 2 would give me 32, and in fact it's also telling me that the 5th power is the correct answer. So if I raise 2 to the 5th power, I should get 32. I want to do some more, especially with some fractions involved. That gets a little tricky. So in this one, we have -3 is equal to log base 5 of 1 over 125. So the base should always be easy to snag. The base of the log should be the base of the exponential. The log is always equal to the power. So the -3 should be my power. And the 1 over 125 should be the result. So this is really good, again, to make sure that you're good with negative exponents, fractional exponents, all that will come up and can get a little tricky. So remember that if you're raising 5 to a -3 power, that should give you 1 over 5 to the 3rd power, and 125 is 5 to the 3rd power. Okay, so when I read this log off, I'm saying what power should I apply to my 5 if I want to get 1/125th? So I know it needs to be negative to get me that reciprocal, to get me that 1 over, and then I need to find the appropriate power of 5 to get up to 125, and it turns out that that is a 3rd power. Okay, the next one, the base of the log is 1/3, so that should also be the base of the exponential. The log is equal to -2, which means that's my power. And I'm taking the log of 9, which means that should be the result of raising 1/3 to the -2 power. Again, negative exponents give you reciprocals, so 1/3 to the -2 power is the same thing as 3 to the +2 power. So if you want to eliminate the negative sign in an exponent, you flip over the thing that's raised to that power. And 3 squared is in fact 9, so I do believe this is true. And again, you want to just take a step back and look back at the log and make sure you're thinking about what this means about logs. So the question here, if I didn't know the answer, would be, what power should I apply to a 1/3 if I want to turn it into a 9? So I need a negative power to flip it, and then I need a second power to turn the 3 into a 9. Okay, last one. There's a variable in the mix here, and this is actually just really early intro to how we're going to approach solving log equations. So if we want to rewrite this in exponential form, the first thing we need to do is recognize that if the log does not have a base, that means it's the common log, and the base is 10. So if you see a log with no base, you can automatically assume that that has a base of 10. The log equals a power, so this should be 10 to the 3rd power. And the thing inside the log should be the result of raising 10 to the 3rd power. So this is a very simple log equation, and this is its solution, 10 to the 3rd, 1,000. If x is 1,000, then the log of x will be 3. Okay, so this is switching from log to exponential form, and my heads up for working on homework like this is just make sure you stop and take a second to really think about what's going on with the log. This homework is really easy just to kick on autopilot and just kind of crunch through and convert them all and not think about it. And if you do that, you're not going to get a lot from this homework in terms of trying to understand how logs work. So really take a second after you've rewritten it to look back at the log and compare the two and try and understand what the log is actually asking you to figure out. For the second example, we're going to go the opposite direction. So we're going to try and take an exponential statement and turn it into a log statement. So the first one, 3 squared is equal to 9. You want to look for the part that has exponent stuff going on so that we can take it apart and make a log. So I have the exponent stuff going on over here, base 3 power of 2. If the base of the exponential is 3, the base of the log should also be 3. Remember that a log always equals the power. So the power here was 2. And the thing inside the log is what results if you raise your base to that power. So if we raise 3 to the second power and get 9, we would say as a log statement that the log base 3 of 9 is 2. Again, which means exactly the same thing as saying I need to raise 3 to the second power if I want to get 9. For the next one, I see the exponent stuff on this side, so I'm going to go ahead and use a log base 4. I know the power should be -2, which means the log should equal -2. And the result should be 1/16, so that's what I'm taking the log of. This is another good one just to test yourself and see if you're good with negative exponents. If I raise 4 to a -2 power, to get rid of the negative sign, I would make it 1 over 4 squared. And 4 squared is in fact 16, so that's how I know that it is true that 4 to the -2 is 1/16. Okay, for the third one, I see exponents happening on the left again. This is going to mean that my base, this base e on the exponential is going to mean that the base on my log should be e as well. And remember, if the base on your log is e, you actually step away even further from the notation than common log, and you use an ln. Log base e is called the natural log. We're abbreviating ln. We know that the log should equal the power, and here the power was -1. And the thing that results from raising our base to the -1 power is a 1 over e. So that's what goes inside the log. So here, when I read this log, if I didn't have the answer, this would be saying what power of e will give you 1 over e? And the answer is -1. So what power of your base will give you the thing you're taking the log of? Okay, last one, I see powers on the right. The base of the exponential statement is a 10, so the base of the log should also be a 10, but that is another one of those special cases where if the base of the log is 10, you don't have to write anything. We use that often enough that we gave ourselves a lazy way to write it. We know that the log should equal the power, and the power is 1/3, so the log equals 1/3. And we should be taking the log of the thing that you get when you raise 10, the base, to the 1/3 power. So again, if we were looking at this, which will be our next step, as a log, and we were trying to figure out the answer for ourselves, we would say, okay, this has no base, so it's a base 10. What power of 10 will give you a cube root of 10? 1/3 power is a cube root, so that's a really good review thing as well. 1/2 power is the square root, so let's see. Let's just say it like this. X to the 1 over n is the same thing as an nth root of x. So this is just a little review note. So if you have a 1/4 power, it's a 4th root. If you have a 1/5 power, it's a 5th root. And maybe even better than that would be to say that, I guess we'll go that way. If you have x to the m over n, that's the same as the nth root of x to the m, or the nth root of x all raised to the m. Give or take some domain issues, it should work in either order. So those are good ones to keep in mind. Fractional powers mean the bottom is the root you're taking, the top is the power you're applying. If the top is 1, then you're not applying any power and you're just taking the root. All right, thanks for watching.